Hi, welcome to Pre-Calculus. My name is Mrs. Kowach and I'm a teacher at Kaufman High School. I have geometry and calculus next year. Pre-Calculus is going to give you the skills needed for calculus and hopefully you remember some of your geometry. I'm going to show you a video right now from 3 Blue, 1 Brown, one of my favorite channels that shows you a little bit of what you're in for calculus, and then I'll come back and explain what is in this pre-calculus course.
A lot of other hard problems in math and science can be broken down and approximated as the sum of many small quantities. Things like figuring out how far a car has traveled based on its velocity at each point in time. In a case like that, you might range through many different points in time, and at each one multiply the velocity at that time times a tiny change in time, dt, which would give the corresponding little bit of distance traveled during that little time. I'll talk through the details of examples like this later in the series, but at a high level, many of these types of problems turn out to be equivalent to finding the area under some graph, in much the same way that our circle problem did. This happens whenever the quantities that you're adding up, the one whose sum approximates the original problem, can be thought of as the areas of many thin rectangles sitting side by side like this. If finer and finer approximations of the original problem correspond to thinner and thinner rings, then the original problem is going to be equivalent to finding the area under some graph. Again, this is an idea we'll see in more detail later in the series, so don't worry if it's not 100% clear right now.
There are a lot of physics problems like this one that need calculus to solve. Consequently, you need a strong pre-calculus background to do well in calculus. This year's virtual pre-calculus course in Schoology looks a little like this. It's broken into modules. I think there's about 4 per semester. And each module then has a place for you to submit your notes that you got from either the video lectures or the book. There is an optional peer discussion or place where you can ask each other questions and the teacher can respond there too. There is a placeholder for your grade for all the required assignments in ALEX, and there is a final module grade at the end of each module that is based off of the knowledge checks and the learning path in ALEX. Let's go over to that real fast. A lot of my students would skip over the videos and get right to the assignments. Please don't. Please don't be like my students. This is a list of the things that you have to do. You can find that in ALEX. There are some mandatory assignments called homework. They're usually just a few questions based off of a topic or a chapter in the book. I'm going to show you where to find that book in a minute. After you do some homework, there is the objective where you're on the learning path in ALEX and you're doing some of the same problems. You want to show mastery of those problems because then you can accelerate through that path faster. When you feel like you know all of these, then you can go ahead and take your post-knowledge check. You do need to realize that you only get one attempt at the post-knowledge check, which is like your test, whereas the homework assignments, you get multiple tries on problems, and there's hints, and there's help buttons that you can click on to see another example just like it. So like I said, I would have students that might not do the videos and just have the ALEX samples teach them. But I feel like you're going to get a richer experience if you look at the book. So where you can find the book, sorry, I have to log back in. So where you can find the book is on your home page. There's a little icon. If you just click on that, it brings you to our Miller textbook and all the chapters. Our modules are in a little bit different order. We start with chapter 8, systems, and go to matrices. That's one module. The second module is functions. The third one is going to be rational and radical functions. And finally, for this semester, we end with exponential and logarithmic functions. So there's a lot of study in functions. And if you were to click on any of those chapters, they give you the section numbers here. If you click on any of those section numbers, here I'll do 1.8. That is where you can find the videos. They are tiny, but in blue, lecture Introduction to Operation Functions. When you click on those, it brings you to the media page and right to that video. Now, on the media page, there are other videos, and we have provided you a list of the videos that I'd like for you to watch. I went through and selected not all of these. Please don't get overwhelmed. I selected a core group of videos for you to watch, and as you can see, they're between probably 2 and 5 minutes long. So don't ignore these. This is like your class time. So really short videos that give you some information. The Alex gives you some practice with those problems as you work through the path. And another thing to recognize with the learning path, back to these assignments here, that you can improve previous scores as you show mastery with this path and future post-objective knowledge checks. It actually goes back and replaces some of your previous scores. So you want to continually show improvement or mastery. This is more like a standards-based grading where you get multiple attempts. You don't get to retake this test again per se, but then the next post-objective knowledge check might have some things in it where you can show that you've improved, and then your grade can improve. So back to how you're going to be scored here. Most of your grade is based off of this learning path. It's about 75% showing that you have mastered and done these topics. The homeworks that are required are 10% of your grade. The video note submissions here and here, those are 5% of your grade. And then at the end of the semester, you will take a semester exam for 10% of your grade. Good luck.